So please thank you, Megan, because we heard that you're not feel okay, and thank you for being here. Your effort and your passion, it's inspiring. So thank you very much. So and please welcome Meghan Kane on the stage.
Hey everyone, thanks so much for coming to my talk. I know it was rescheduled and some people had to head out a bit early, so I really appreciate the people who came out. So today we're going to talk about getting started with machine learning in your iOS apps. It's a really big topic. I'm not going to claim that I'm going to teach you everything you need to know about machine learning in this 30 minutes, but I want to cover some of the terms maybe you've seen before, so demystify them, and give a little bit of the lay of the landscape of what's available right now for your iOS apps. So yeah, I haven't met everyone before, but just an introduction. I'm an iOS engineer at SoundCloud right now, based in Berlin. I did have I got a degree in math and computer science, so I do have a bit of a background in artificial intelligence and machine learning, but it really was like nothing practical until like very recently. So please don't be like discouraged by that. Like I don't have a ton of background in this. I'm kind of like on the same page as everybody else here. So for today's agenda, we're going to go through why and when you would use ML in your iOS apps, because it's kind of a new concept. Give a crash course in ML foundations. We'll see what's available now, and most importantly, tools for learning, because since it is such a large field, it's really important to have an idea of how to navigate all of the tools that are available. So machine learning, since it is such a broad topic, how do we define it? So if you distill it down to its simplest form, we're trying to enable machines to learn just like babies do. Like you don't tell babies exactly what to do. They kind of just pick up on their environment and learn from there. So Arthur Samuel, who's an AI pioneer, defined it as the field of study that gives computers the ability to learn without being explicitly programmed. Some common examples of machine learning that probably everyone has seen before, but just so that we can like get the topic started, is image classification. So this is a picture of the SoundCloud office dog, Perun. And if you give a machine learning algorithm this picture, you would expect the machine learning algorithm to detect that this is a dog, just as a human does. And you've also probably seen that machine learning is used to detect faces in photos. Apple does this. Tons of other third-party apps do this. It's pretty common in the past couple of years to utilize machine learning for this. It's also used for recommendations. So in SoundCloud, and also like Spotify does this as well, you don't always know exactly what you want to listen to. So it's easy for a user to just pick a track and then start like a station, which is a passive listening experience where we just send them recommendations that we think they'll like based on their previous tracks that they listen to. Machine learning also can recognize handwritten digits and then detect what they are, even if the handwriting is a bit sloppy. So, I mean, these are just some examples. The options are pretty much endless in this field, so it's a really exciting place to look. So, yeah, I went over some of these examples just for the reference for the slides if you look at them after. So yeah, ML enables a more personalized experience. Personalization and identification can really help users. Sometimes they don't know like what they want exactly. They don't have the vocabulary to describe it perhaps, or they can't really think of it off the top of their head. So if you show it to them, then like they kind of know it when they see it. So recalling is harder than recognizing. You can see this in a lot of different topics. So why and when would you use ML? Yeah, so mostly to personalize user experience. So you would use machine learning in like a variety of different places, both in the cloud, on your own hardware that you run on your servers, both in your office or hosted somewhere, or on the device. So we'll take a look at a couple of those. And Apple has released to us Siri Kit, and they've also been dogfooding the ways of using machine learning on iOS in face recognition in the Photos app. So before we get started, this is the last product focus slide. How do you go about it? Because when you introduce like a methodology that's like fairly large into your app or any type of feature, I think it's really important to make sure that you know why you're doing it, because otherwise you can kind of get lost in the shuffle of what is this really doing for us. So I think it's wise to first like identify a key performance indicator or KPI of the app. So for example, for SoundCloud, this would be something like listening time, the amount of minutes per day that the average user listens. And then you might want to formulate a hypothesis about how machine learning impacts this KPI. So for SoundCloud, if they were to introduce a new machine learning like algorithm for recommendations, maybe they would expect the listening time to go from 30 minutes to 38 minutes or so. And then you want to conduct the experiment as scientifically as possible so you can measure results. So try to isolate it to just machine learning so you can track this instead of like shipping 20 different features at once. So it's hard to isolate where this improvement or no, lack of improvement came from. So yeah, and then measure the performance before and after. So now that's the product side of it. The crash course in ML fundamentals. So you've probably heard lots of these terms: neural networks, deep learning, like convolutional neural networks, that like XYZ. There's a million different terms thrown around: training, inference. What do they actually mean? So for machine learning, like you're coming up with like an equation that's going to help you predict some sort of results from data. And in order to do that, you need to make a model. And so the model is going to be that system that makes the predictions or identifications. Neural networks are the ones that we're going to focus on, the machine learning model. It's just one of the ways that machine learning is like implemented. There's tons of other ways that have been done like over the past 50 or not more years, and this is one that's like been taking off recently, and it's the one that's relevant for Apple's APIs. So neural networks, the goal is for the network to learn by itself like a brain. It's a highly interconnected network of neurons or nodes, and it's dynamic, so it processes input and updates its state as a response to that input so that it learns over time, just like a brain would. There are lots and lots of types of neural networks. There's actually something called the neural network zoo you can come across pretty quickly if you Google for neural networks. So we're just going to focus on like one or two. Don't try to get distracted if you're looking up neural networks by like the millions of neural networks they've come up with. They all have a different purpose and they have different topology, but you can just concern yourself with one for iOS. So what does a neural network look like? Kind of like a bird's eye view. So you have the input data, and then you have the output data at the end. And then what happens in between is you have like many layers. This is just a very simplified version. You may have like, I don't know, tens, hundreds or so layers of transformations of that data along the way. So each synapses, which is the circle, is an input. Each synapses input is the output of a neuron, and the synapse carries a weight, which will translate into the equation that you're going to use for the model, and the output is equal to the input times the weight. So that's just like that's all the math I'm going to do. Like we're not going to go into like linear algebra and everything that probably no one wants to look into. And so you have a basic model, and you need to train this. So people have probably heard of this before. So I'm not going to go through like all of the details, but I just wanted to like show. Is this playing? I just wanted to show like. I can't tell. I think it's paused. Okay, I'm not sure what this audio is, but the gist of it is like over time. It's not, okay. Yeah, over time, you're going to send data through this neural network. And it's going to go through all of these different layers. And it's going to, like when you pass through the neural network, it's going to, it has an expected result, and it's going to compare that expected result with the actual result that was determined by that neural network. And then it's going to use that error margin to back propagate to the neurons that came before it, and then try to improve the network over time. So if these synapses are getting big over time, that means that they're basically synapses like in your brain. If they're firing like very rapidly, then there's a lot of activity going on there, and it's a sign of importance. I apologize for this like horrendous soundtrack. I don't know what that is. I wouldn't have chosen that. Okay, so we have the model, and we've trained it, and so what do we do with that? So once you have the model, then you have a basic way of describing the system, and so you're going to use this trained model on inputs to predict the outputs for whatever you're trying to do. If you're trying to look at photos to detect a dog, then your input would be the picture of the dog, and the system would predict whether or not it's a dog or a penguin or a zebra, and it will give you a distribution of what it thinks it is. That's like a very simple use case of it. So where is this all done? So right now, like Apple came out with 2 API offerings, which we'll go over later, but those allow inference only. So at this point in time, inference can only be done on the device, which makes sense, right? Because training a model is extremely computationally expensive, and so you can't feasibly train on the device right now. It's actually like prohibitively computationally expensive to do right now. If we were closer, maybe it would drain the battery like immediately. It would, in one way or another, cause a pretty poor user experience. So you can use inference, but that does still provide value. So then, since you only can do inference on the device, you need to have a pre-trained model to run inference on. So you need to get that model from somewhere else. So there are many different pre-trained models out there, and I'm going to go through some examples, but you're likely going to do this somewhere in the cloud, like a service that's provided for you, or do your own in the cloud, or run your own servers. That would be like the logical extreme, or run your own machines to do it. So where do you get the model? So the most popular way of doing this, and it's really valuable and is really improving rapidly over time, is TensorFlow, which is a Google provider. So TensorFlow is a provider where you can use TensorFlow. It's free, open source, to do training yourself and create your own models. And you can also go to their GitHub page to their open source models that they have out there already. So there's, maybe 25 or so trained models, and there's excellent documentation. I've linked to it in the slides. So I would say that's probably the best option, has the most documentation and blog posts written about it. But there's also like a lot of other options. VGGNet is one that's used pretty heavily. I think it's used in academia a bit. There's also a lot of blog posts about that. And then there's other ones too, and they're kind of like popping up like every month or so. If you listen to the This Week in Machine Learning podcast, you'll hear another one pretty much every time. Okay, so let's cut to the chase. How do we actually use the Apple-provided APIs? So at WWDC 2016, Apple introduced, with iOS 10, they introduced 2 APIs for running inference on the device. And these are both using convolutional neural networks. This type of neural network is best for describing objects in a given photo, so like recognizing the dog in that photo. The 2 different APIs are kind of a mouthful. The first one is BNNS, Basic Neural Network Subroutines. This utilizes the CPU. And then there's the Metal Performance Shader Convolutional Neural Networks, MPSCNN for short, and that utilizes the GPU. I'm going to just say the Metal Framework from now on, because it would take up so much time to say the full title. And the Metal Framework, it heavily utilizes the GPU, and it's most suitable for processing images and videos. So to do image recognition, that would be the most useful case of it. It makes sense, right, because this is also used in other ways, this framework, with different APIs for game development and other development that heavily utilizes the GPU. Since it does that, there's a very big performance benefit that you can get from this, which is the massive parallelism that GPU offers. But then a drawback is that in order to use this, when you're loading your data model into the framework, you have to first translate it to an MTL texture object, which is quite a bit of overhead. And then at the other end of it, when you're reading out the results of the inference on the model, you have to translate it back from an MTL texture object to whatever you're trying to work with. The BNNS Accelerate framework, this utilizes the CPU. This has been recommended that it's most suitable for processing time series data. It's a bit easier to use, I guess some people would argue, because it doesn't require like as much knowledge of some GPU concepts as Metal does, and it doesn't have the upfront cost to loading the data into the texture. But then again, it also arguably can't have like nearly as good performance because it doesn't take advantage of the GPU parallelism. So it's really whatever your needs are, and you can also measure this over time. You could try using both, or run an A/B test of using one or the other if you want to try them both out. And there's also a really good blog post by this guy Martin Hollemans from the Netherlands, and he compares the performance of both, and I linked to that in the references. So performing image recognition with Metal. This is like the standard use case of getting started with machine learning, and Apple provided a really good sample at WWDC 2016, and they've maintained it through at least like the end of 2016. So it's like up to date for the most part with like any changes that were made to the APIs like after the beta. Like I encourage you to check that out as like the first source to look at. So the point I want to make about like using this first is that the hardest part about this is actually taking that open source data model from TensorFlow and translating it from the format that it's in to some Swift. There's like a lot of heavy lifting and scripting that would come in handy. So I hope you went to John Sundell's talk for that. For like a reference, this image recognition model that they used was the TensorFlow trained on Inception V3 network. It's like a very standard network, and it's 3,020 lines of Swift when they translated these, like, I think they're called DAT files. It's like a binary of like 30 or so files of this data model into Swift. And so to do that yourself is like something that's like a bit tedious, and while you can learn to do it, Apple provides this for you in their sample, and you can just use this because this model can recognize images for like many objects. So you can just like use this one like Swift file and use it in your app. It probably is like provided as like a, I don't know, in some sort of like CocoaPod or some dependency management system. I can check into that. So I checked out how this Apple sample worked on. I've run it on a bunch of things like in the past, but I just ran it actually right before I came here, just to have like a more up-to-date example of a picture of my bike that I built when I came here. When you run this sample that Apple provided, can it detect that this is a bike? And can it detect that it's like a specific bike? And turns out it is. So the way that you use this sample app is you just take a picture of what it is, and then automatically it runs this model, and then it gives you a distribution of what type of object that it thinks it is. So with 83.35% accuracy, it predicted it was a mountain bike, all-terrain bike, off-roader. That's pretty much right. It's a road bike. And 3% accuracy, it thought it was a tandem bike. So so it's like statistically significant that it predicted the right type of bike. So it's a pretty reliable model from this one sample, and I've run it on tons of other ones. So pretty good. Okay, so what did we just learn? There's like a lot to follow, but it distills down to the first step is getting that pre-trained model. So for example, the TensorFlow pre-trained models that are provided in their GitHub page that I linked to. And the second step is translating that model format to Swift or Objective-C. So you can do that using, if you want to do image recognition, just like save yourself time and use that Apple example. If not, then there are other ways to, there are other resources for helping you with translating this, the format into Swift or Objective-C. And then use Apple's Metal framework or Accelerate framework to run inference on the device, and then take those results and measure them. like, is this is the model working, and is it also helping your KPIs and helping your app serve your users to make the experience better? So why would you want to do inference on the device? Like, it is probably a lot faster to do it like in the cloud or like on your own Mac Pros or something. Like, obviously, there's no comparison. But there are some reasons why you would want to do inference on the device that you can't get from the cloud. And the first one is data privacy. And like in this day and age of increasing or decreasing trust in the system, and like more and more breaches of data privacy, especially in the US where I'm from, people are becoming more aware of risks to apps leaking their data. So if everything's done on the device, that can at least ensure that it's kept on the device, and the data privacy concerns are limited to the device rather than sending it off to somewhere they have no idea where it goes, and then also a security attack could occur on whatever cloud service or machine they're running in their like server center. So data privacy, and the second one is free computing power. So computing power is can be pretty expensive for running some of these models, even just for inference. And so, especially if you're like a freelance app developer or just like a one-person shop, then it could save you some money to do this on the device. And if the user has their phone plugged in, then you don't really risk draining the battery. So might as well just take advantage of the free computing power. And these are the reasons that Apple has noted for why they're running inference on the Photos app to recognize faces. So I've been following this space like pretty closely for the past like 6 months or so when I got back into ML, because I didn't really do much after my degree because it wasn't so relevant until like so recently. And it's interesting to know like where does Apple stand as far as like how are they doing like and benchmarked against like other platforms, like are they ahead of the curve or do they have a lot to do? And the consensus like from some experts is that Apple is like is going in the right direction, and it was a big step for them to release those 2 APIs last year at WWDC, but that they have a lot to catch up with, and like it wasn't really a priority. But I think like it's pretty likely that that's going to change. I wouldn't be surprised if at this WWDC they release something really big, because in the past year they've hired a lot of machine learning experts from industry and academia, and they acquired Turi, which is was a really well-regarded platform for training models. They acquired this in August 2016 for $200 million, and the co-founder he's the professor of machine learning at University of Washington, so very well respected. And they're also making their own GPUs, which we found out as of like I think 2 weeks ago or so. Sometime in the last month we found that out. And so these are all signals that they're probably moving in the direction of heavily investing in ML. And so it's really wise to, if you're interested in this topic, try to get started with like learning more about the terms and how they all relate to each other and what can be done in the cloud versus a device, so that when WWDC rolls around in June, you're ready for whatever they release next, because it could be quite big. We'll see. So I just want to say like special thank you to like there's a lot of like blog posts that I like drew upon heavily since it's such a dense topic, and they're listed in the resources. And the This Week in Machine Learning podcast is so good. Like I really encourage you to start listening to it. They don't like ever go through math equations. They're just talking about updates in the industry, and it's very interesting conversation. And you can keep up pretty quickly. It's like 20 minutes each week or so. And also thank you to App Builders. It was really nice to be here. I really enjoyed Switzerland. It's great. I hope I can go back soon. And yeah, these are the resources. I'm hopefully going to like post a blog post of all this stuff, so it's like in a little bit more like digestible form to go back to. And there's so much that I didn't cover, so I really encourage you to like check out this Apple sample. really try to like go through the source code, and it's pretty easy to follow. That's for Metal, and then for Accelerate, there's also another sample. And I'm gonna be like doing a lot of work in this space soon, so I'm gonna plan on open sourcing whatever I can, so that I can contribute back, so people can follow along with real world examples, since this is so new. So that's all I have.